Okay, so let's get started. So thanks for coming back, everyone. Hopefully you've had a good week playing around with Python a little bit since last we met. This particular comic, today's comic, I think is relevant to our mission here, although we're doing Python and not Perl, which is a different programming language. But still, my hope is that, this will at some point be useful to your future career in some way or another. Maybe not more so than your other classes, but somewhat helpful. Okay, so today's topic, official topic, is talking about simple. Hello, guys. Come on in. We're just getting started. You're not interrupting the podcast at all. It's not quite as professional as some podcasts. Okay, so today the official topic is simple input-output and program flow. We'll talk about what that actually means in just a second. So before we get started, some administrative stuff to talk about. So hopefully everyone got my email. If they did not, let me know and I can give you the links and stuff. So there's a regular Moodle module for this class, but so that people that are not officially on it in Moodle can access everything, it's actually all in a Google Drive folder, everything you will need. So I think what's in there so far is last week's lecture slides as a PDF and a text file and the first problem set, which hopefully you've all managed to access, and just a text file with random information in it, as well as the links to the podcasts. As you probably saw in the email or saw online if you tried to access the podcast software broke for the second half of class last week, but I think I know why, and I think that won't happen again. So hopefully, if you need to refer back to this lecture, you will have a complete podcast from this week's episode. And if you're not watching the podcast, that's fine. I'm still getting PGCHE credit for it either way, so, all right. So hopefully everyone has at least taken a look at the problem set. If you have not, you have until Friday, 1 minute before midnight, to submit it. If you're you don't have to do it if you're not an undergrad officially enrolled in the module, although I recommend you look at it if you're, just auditing. If you've already submitted, I think, so some people have already sent it in. If you learned something today that, means that you think you got something wrong, I will let you resubmit it, until Friday at midnight, and I will take the last version you submit. So, I haven't really looked at anything anyone submitted yet, so I'm not trying to hint to you that you did get something wrong. But if you do need to resubmit, or you think you did something wrong, you may further attempt to get it right until the last thing you submit. I won't necessarily do that for all the others, because that's a lot of emails, but this first week, that's okay. Okay, any other questions or anything in general to talk about before we jump in? Anybody got questions or issues or anything? Okay, so like I said, this week is going to be much more hands-on. The lecture/workshop divide is not going to be really particularly sharp this week, so it's really going to be sort of alternating talking and playing around the whole time. Okay, so let's jump right in. So we are going to go much slower today, much more hands-on. So actually, if you haven't already, you may as well go ahead and start up PsychoPi. In theory, all of the machines, I think most of them should now have the current version of PsychoPi on them. Maybe before we leave today, I'll have you check the versions. But for what we're doing today, any version should be fine. But for next week, we'll want the latest version because we'll start actually projecting stimuli using PsychoPi. And for that, we'll want to have a later version. Okay, so we do have just, go ahead and be starting up PsychoPi, but we do have one little topic to introduce before we start poking around with PsychoPi code and Python code in general. And that's to talk about the idea of variables. So one of the things that you're going to use a lot of in your programming class is variables. And to just introduce this topic, so really, if you reduce down what a computer does to its very simplest elements, it only really does a couple of things. It stores some sort of information in memory. It can then manipulate that information in some way, so you add two numbers together, or multiply them, or divide them, or move something from here to here, or something like that. And then you can store the new information again, okay? And that's really all that's going on, right? It's just lots of computations on bits of information really, really fast. And of course, you could say, oh, well, what about communicating with USB devices and, printing and stuff like that? And that's sort of true that that's a different thing, but it's still mostly the same thing. I mean, 90% of what you're doing when you're programming your computer to print out a document or something like that is still moving information in memory around and changing it. And then eventually just a little bit of it gets sent over a wire to the printer. But most of what you're doing is just changing and restoring information. And you could actually, kind of say the same thing is actually true of your brain, right? All it really does is store information, sometimes take it out of storage and change it around and manipulate it a little bit, and then store it back again, right? So in order to do that, you really have to make a few choices. So you have to kind of choose what sort of information you're working with, how you want to change or manipulate it, and what order you do it in, right? And those are the basic elements of computer programming is what information am I dealing with, what do I need to do to it, and what order do I need to do something to that information in order to get the result that I want, right? So today we're going to do all of these things in a very simple format and work out sort of what it is to write a simple computer program in Python. Okay, so just to introduce the idea of what a variable is, we're going to have some hopefully not too traumatic flashbacks to your algebra class from, I guess, I don't know, when you were probably about 12, 13, something like that. So I don't know how they teach mathematics in other countries than my home country, but let's say you had an equation like this. Presumably everyone has solved an equation like this at some point in their lives. And if you've got 4x plus 7 equals 39, then you can subtract 7 from both sides of this equation to get 4x equals 32. And you can divide both sides of the equation by 4 to get x equals 8, right? Everyone remember doing this as a young tweener who was very excited about algebra? So this is an algebraic equation, and what do we call x here in this equation? I'll give you a hint. It's a word on the slide. What's that? Yes, it's everyone. No. Okay, so x is a variable, right? So a variable in programming, like it is in algebra class, is a value that is represented by some sort of abstract label, like a letter or something like that, some sort of name that we give it, when we don't necessarily know what the actual number is, or we don't want to refer to the number by a number every single time. Okay? So basically, just like in algebra, if we use variables when we program, that'll let you give a name to a certain value, right? And there's lots of reasons why you might want to do that. And we'll see some of those today. But there are some differences. So how you've used variables in algebra is different than how you'll use them when you're programming. So just for a short rundown of those. In algebra, the variable represents a value that you usually don't know what it is, right? So when we started out that equation in the previous slide, you didn't know what x was. You knew that 4 of it, what did I say, minus 7 was the 32 or 39 or something like that, whatever it was. So you don't know what x is to start, right? I mean, you spend your equation in algebra trying to figure out what x represents. Usually, only numerical values are represented by algebraic variables, right? The value never changes, right? So you don't always know what the value is, but it is always the same, right? So you're not changing what x represents. And you usually just use one letter, like x or y or n or whatever. So in contrast, in programming, you often know what the variable is that you're using. You're often the one that decides what the value is, right? So you might say, this x is going to be 12, or this variable is going to be 15. Or sometimes the user might set it, or sometimes it might be something you calculate based on values that you set or that the user set. But often you actually know what it is. You don't have to solve for a variable. You assign a value to a variable. It can be a numerical value, but it can also be lots of other things. So it can be like text. A variable can represent an image, or all kinds of any kind of information that a computer could process. You could have a variable representing that information. In programming, the value can change frequently, so you might assign a new value to a variable depending on some calculation you do. And it can be, within reason, pretty much anything you want. So In algebra, because you're writing long equations, you usually just call the variable like x or y or something like that. And you often make a note to yourself at the top of an equation like x is the number of apples that John has, and y is the number of oranges that Susie has, and then you solve some systems of equations or whatever. But variables in programming can be named pretty much whatever you want. So you can name it, Billy or whatever. But usually you want to give a variable a descriptive name so you know what it represents. And we'll very quickly jump in and see what that means. Okay, so like I said, you can use variables to represent lots of different types of data, but right now we're just limiting ourselves to a few simple things. Integers, hopefully you all know what integers are, whole numbers, positive numbers, negative numbers, 0. Bits of text, which in the programming world we're going to call strings. So if I talk about a string, it's okay. I'm not talking about a physical piece of string. I'm not talking about string theory. A string is just a string of letters, a sentence or a few words, or it could just be one letter, but it could be a bunch of letters. So any chunk of text we're going to call a string. And the last thing that we'll deal with today are what we call Boolean values, and that just means true or false. Okay, so Boolean logic is the sort of branch of mathematics or logic that deal with the truth of statements. So when we talk about a Boolean value, we really just mean whether it's true or false. Okay, these are the only 3 types of information we're going to work with today, but by the end of the day, we will have done all 3 of these things. Okay, so are you guys ready to jump into some PsychoPi? Everybody got it started and everything? All right, so let me do the same. So again, if you missed the demo last week, if you forgot the demo last week, if you're completely lost, that's okay, because we're going to start over from kind of the beginning. So open up your PsychoPi. Make sure you're in the coder view. We don't care about the builder view. Builder view is not our friend in this class. And if you want, I know you're on Windows and I'm on a Mac, but if you want, check the About box. And in theory, if you're up to date, you should be on version 1.744.03. I can't remember exactly where that menu is, but I think you can probably find it. If you're not up to date, we can talk about that at the end of class and make sure these all get updated by next week. Okay, so you're in this coder view, and you'll want to make yourself a new code file. And actually, go ahead and save it. Give it some sort of name, because you'll need to save it eventually. I'm just going to call mine, let's call it lecture to, you can call it whatever you want. Actually, let's make it the name shorter, because we're going to need it to refer to it a lot. Let's call it lecture to demo 1, lect to demo 1. But you can call it Fred, or you can call it Ian Steven, or whatever you want. So far we've just created an empty text file here, okay? All right, so we're just going to do a couple little lines here and see what happens, all right? So, oops. Oh, also, you guys complained about my white space. If you need to turn off the white space, it's under the view menu. All right, so first line, I'm just going to say sum underscore number equals 42. And then print space sum underscore number. Okay? And I've saved that. So everyone, write down those lines and save them. Everybody got them? All right. So now you can try running this code. And what do we get in our output? 42, yeah. You can ignore this line here with all this is just sort of saying we ran a new script, right? So it printed out 42. All right, so what did we really do in these lines of code? So in line 1, hopefully we can break it down. This is pretty simple, right? So in line 1, we made up a name, right? We made up a name called some number, right? And we have an equal sign. And the equal sign means roughly the same thing in Python that it does in algebra. It means that two things are equal. But the difference is, in algebra, you're sort of stating as a fact, like x equals 7, right? You're solving the equation to find out that x is equal to 7. Here you need to think of that equal sign as being a little bit more of a command, like some number, you are now 42, right? You are assigning someone to a number. It's like when you say, all right, you're on team A, you're on team B, you're on team A, right? So you're saying some number, I am creating you and naming you, and you are going to be 42 until I tell you otherwise, and you better like it. So that's what you're doing in that first line there, right? And then what is line 2 doing? It says print some number. So what is that doing when I tell it to print some number? Right, so it prints out the number 42. So it doesn't print out the word some number, right? So clearly so in other words, this is your way to give a name to this value, right? So the Python interpreter sees some number and it automatically substitutes in the value that you've assigned to some number, right? Does that make sense to everybody? So it's just, like if you are human being number 4823785 in the world, but I'm going to call you, whatever, Matt Johnson, So that's an easier way to refer to this, some piece of information than by its actual value, right? Okay, so is that enough explanation for 2 lines of code? Everybody cool so far? All right, so let's add in a couple. I'm trying to go slow so that this all makes sense. All right, so we're going to add in a couple new lines. So let's call this new variable sum underscore text and a single quote. You may remember this phrase from last time when we also played Hello World. So call this text Hello World, and let's try printing some underscore text and saving that. You guys are going to get to learn what a terrible typist I am in this class because you'll see me doing this live. Okay, so everyone's got that there. So we've got some text. We set that equal to Hello World. We print it out. And then we can run it. And what do we get there? So we still get 42, right? Because we didn't take out the line telling it to do that. And then under that, we get Hello World. All right, so we're doing a similar thing here, but some number and some text are going to be different types of variables now, right? So what would we call the type of information that's in the variable sum underscore text? I think I heard a string, right? So some number is an integer value, some text is a string, right? And that's because we told it, we told Python by assigning 42 to this value and assigning hello world to this value, we told it, what type of information is in each of these variables, right? Now, a few key things to note about this, right? So when we had 42, we just wrote 42, right? And it knew that that was a number. And you'll see, actually, I'm not sure how the highlighting is set up on Windows, but you'll see that it even, for your convenience, it highlights numbers in a different color, right? And similarly, the string probably shows up for you as pink or some color like that. And what do you notice about the quotation marks? So when I put the quotation marks in, did they show up down here? Okay, so the information represented by some text is not quote, hello world, unquote, right? The information that's in that variable some text is just the words hello world from the H to the exclamation point. So the quotes are just our way of saying this is a string, right? Because otherwise, it's not clear to Python whether this is, if I were to just write this without the quotes, we can try that and see what happens. Okay, it gives us, if you've tried this in your homework, it gives us what you should be familiar with, a syntax error, right? Because if we don't somehow clue Python into the idea that this is a text string that we want to be represented literally as text, it doesn't know is like hello supposed to be another variable name, or what is that really? Like what are we trying to say by that, right? So it doesn't know if we made a typo or just don't know what we're doing, which is all possible. So in order to tell it this is a string, we have to put it in quotes, right? So just like in a book, where you put things people say in quotes to indicate that they are exactly what the person said, we put text strings inside quotes in order to say, hey, this is a string, not just some other bit of code. So treat it like a string. All right, everybody cool so far? Everybody fully understand these 4 lines of Python code? Okay, cool. So let's try one other example. We won't beat this down too much, but want to make sure everyone's on the same page. So let's say some truth equals true, and print that out. And you should be able to run that as well. Okay, so you should get what I get down here, right? 42, hello world, and true, right? Sort of a very Zen message if you try to make some sense out of it. Okay, so some truth is that third example of a kind of variable I told you about. This is a Boolean value, right? So some truth could only contain two possible values and still be a Boolean value. It could be true or it could be false, right? So you can change that to false. That's fine. But if you wanted to say like maybe kind of true, you know, which is a kind of truth there is in the world. So then we get some error, right? We say, well, that doesn't work. There's no such thing as maybe kind of true, right? So in other words, Python recognizes the word true as a value, meaning true, right? And it recognizes false as being, you know, something that's not true. It doesn't recognize most other words as being anything special, right? So notice that you don't put this in quotes, right? Because then if you put it in quotes, you would get the exact same type of output, right? But then some truth would represent the word true. It wouldn't represent the truth. You know what I mean? Does that make sense to everybody? So true or false are like ones or zeros, right? Like yes or no. So this is what you would use if you want to indicate whether some condition in your experiment is true or false, right? You wouldn't use the word true or false. You would use the value true or false. Does that make sense to everybody? And just as a little side note, in sort of the bowels of the computer, usually trues are represented by ones and false as zeros. So this is just really kind of a convenient way for us to refer to true and false things, but it's kind of a little bit better than using 0 and 1 because then it's sort of clear when you're using numbers and when you're using truth values. Okay, so is everybody clear on these 6 lines of Python code? Everybody cool with that so far? All right, excellent. So we've just created 3 variables of 3 different data types. We've assigned values to them, and we've printed them out, right? And we've seen now the print statement knows how to interpret, how to print the variable when you refer to it by name. Okay, so let's switch back to lecture. Keep going here. So that's kind of interesting. That'll be helpful, but we can't do much interesting yet. So the next thing to talk about is input and output, okay? So obviously if we want to do anything interesting, you usually have to do something like take in information from the user, do something based on that information, and display some kind of result, right? So for this class, what you're probably doing is having the user do a cognitive task of some sort. You might do something based on that information, like make the task harder, or record their reaction time, or give them some feedback, or something like that, and then display something to them as a result of that, right? Now, eventually, the output that we'll be doing is drawing on the screen, right? Because PsychoPi will let us draw shapes and pictures and all kinds of stuff on the screen. And, we'll be able to use the mouse if we want to, but for now, we're going to kind of do things the slow and simple way, the way that they did back in, like, the dark ages of the 70s and 80s, by where all the output is text and all the input is keyboard input, okay? So we're just going to work on printing text and typing in commands today, and then next week we will actually start to do real PsychoPi stuff. Okay, so just to let you know, there are a million ways that we could do input and output in Python. So Python the language, not even worrying about PsychoPi, the software for doing psychology experiments. Python can do all kinds of different inputs. So we could draw on the screen with Python. We could, produce sound output or whatever. But for today, we're just going to stick to the very simplest ones because really we're not going to use these much once we really start doing PsychoPi. We're really going to start using PsychoPi commands. So for today, just for illustrating the concepts, we're going to use the print command to display text on the screen. You've already seen a little bit of the print command, but we'll see a little bit more now. And we're going to be using something called raw input to get a line of text input from the user, okay? So again, there's lots of other input and output functions in the Python language, but we're only using these 2 to keep things kind of simple for today. Okay, so you guys ready to try those out? Everybody good so far? All right, so You can keep those other lines of code if you want. One thing we're going to have to do, this is a weird little thing about PsychoPi. So if you want to just like print stuff out to the output, you can use this output tab. If you want to actually interact with your program, you have to switch over to this shell tab. It's almost not even worth explaining why this is. So you can just sort of take it for granted that this is sort of a funky little way of how PsychoPi is put together. So I'll show you, now that we're going to want to interact with our program, we're going to want to switch everyone over to the shell tab, and we're going to run the program slightly differently, okay? So just be aware of that. All right, so let's try something new. So we can say answer equals raw input, and there's some parentheses on the end of raw input. And it doesn't matter if you have an extra line or not, and print answer, okay? All right, so we're going to do that. And now instead of the little running man icon at the top, we're going to go down here, and this is what we did last time. I didn't really explain it. I'm still not going to explain it very much because you know, it's sort of a weird thing about running Python programs within this PsychoPi coder. It's not anything about the language of PsychoPi. But the way we're going to have to launch this now is instead of clicking the little running man, we're going to do exec file and the name of our file name, which for me is lec2demo1.py. So you might have named it something different. So it's going to be exec file, parentheses, the name of your file in quotes, because what you've actually got here is you've got a Python function called exec file, which the help may pop up and tell you that what that command does is read and execute a Python script from a file. Don't worry about the other stuff. And what you're actually giving it is, what are you giving this exec file function as input? What do those single quotes mean? You're giving it a, what is this lec2demo1.py? Well, it's a file. It is a file name, but what type of data is that file name given as? A string. Yay! Right. So this is an example of strings in action right here. Is you're giving the exec file a string, which it's going to put into some variable, and then it's going to do stuff with that. But that's not too important right now. Just note that that's a string in action. All right. So if we execute this file, we get our 42 hello world true, and then we get a little prompt of some sort, and I can put whatever I want in here. So like, hello C83PFP, and it prints that back out again. Look at that, right? Okay, so what happened when we had line 10 here? So clearly this raw input function puts a little prompt on the screen and lets us type something, and as soon as we hit enter, it puts that text as a string into this variable over here. Now we don't have to call it answer. We could call it, you know, Fred. And if we do this, it should do exactly the same thing. Okay, right. So it does the same exact thing as before. So it doesn't matter what you name this. It just should be some sort of informative name, right? So probably what we had before was more informative than Fred, right? Because if we call it answer, it does indicate that it is an answer to some sort of question, right? All right, so does everyone get sort of what happened here? So we have the raw input function. Raw input puts the little arrow on the screen indicating you should type something. When you do type something, it stores that as a string in a variable that you name. You call it answer, right? So instead of saying answer equals, you know, 42 or some text or whatever, you're now saying answer equals whatever the user inputs, right? So you see you're still assigning a variable, but you're assigning the variable a value that is determined by something the user does, okay? And then just like before, we're printing out the string that is represented by the variable answer. Okay, does that make sense to everybody? Are there questions about that so far? We're still cool? Any questions about any aspect of this, why we do something a certain way? Everybody all right? Okay. I don't know if I'm going too slow or not slow enough, so feel free to ask questions as we come along. All right, so let's just to illustrate, that we can do this as many times as we want, we'll do something like this. Okay, so we can get another answer. Oops, I almost tried to run it with the little man. And exec file. Okay, so this is my first answer. Here is my second. Okay, right, so you can get one answer, you can print it out. You can get another answer, you can print it out. Now, if you want to, you could do something like, print them both out again if you want, and maybe switch up the order. Right, so you could do that if you want. Select to demo. Okay. First answer, second answer. All right, so then you see, all right, your print, it does exactly what you told it to, right? So it gets the first answer, prints it out, it gets another answer, prints that out, and then you told it to print another answer again, and then print answer again, and it did exactly that, right? So even after you've used the value of answer or another answer or whatever, the value stays unchanged unless you change it somehow, right? However, you could do something like this. So you take out the another, you do this, just make some blank lines here. Okay, so it's asking for answer. So let's say my first answer is Matt, and my second answer is Johnson for some reason. Okay, so you see, you can easily reassign the value of answer, right? So the first time I ran this, it assigned the value of Matt to answer. The second time I ran this, it assigned the value of Johnson. So if I do this, I'm basically overwriting the old value that was in answer, right? So answer ceases to refer to my first name and now refers to my last name, right? And unless I saved that Matt information somewhere else first, then that's gone forever. That old value is just gone, right? Does that make sense to everybody? So you can assign as many different things as you like to a variable. You could even do something like this. Oops. All right, so we could do this, exec file. Say I'm Peter Mitchell now. All right, so you see what we did here is first I assigned some raw input to the answer, printed that out, and so it prints out Peter Mitchell because that's what I typed. Then I decided, you know what, now I want answer to actually be a number. I want it to be 296. And there it goes. So you don't even have to assign, you can reassign the name of answer to be a different data type, like a number instead of a text string. You can do all kinds of things, right? So the instant I reassign it on this line here, on line 13, answer ceases to refer to Peter Mitchell, and now it refers to the number 296, right? Okay, so let's do something. So let's go back to maybe the way I had it before, though, just to make things easy. Raw input, print another answer. By the way, you'll see if you get one of these little suggestions, it tries to be smart and suggest to you like names that are already in your script. So if it's the right suggestion, you can hit tab to complete it. So like when I don't know if you saw that. When I was starting to type in another answer, it suggests this. If I want to take that suggestion, I just hit tab, and it will fix that for me. So that'll save you some time as you're typing if you get into that habit. Okay, so let's get one last answer. We can even call it one last answer equals raw input. And now we're going to do something a little bit different. So last time we had empty parentheses in here. But now we're going to say something like, please enter your third answer here, my friend. Print. Thanks, buddy. Your last answer was This is a little bit tricky and maybe has some slightly weird syntax, so you may have to make sure you get this exactly right. We'll also get to see if I get it exactly right when I do this. So you might get to see some debugging happen in real time if I type something wrong. Okay, so in theory, I'll let you keep typing, but I'll go ahead and start running my version. In theory, if I type this right, all right, so my first answer is going to be first D, and let's call it second D. And we'll call the third answer Mr. McThird. Okay, so some new stuff happened this time, right? So what are we doing here? So let's look at the first thing we changed from this line. So instead of having these empty parentheses, inside the parentheses, we put a string, right? We put the string, please enter your third answer here, my friend. So what happened when I put that? Are we having things not working? We good? Okay. We want to take a stop and fix things that are broken break. So where are we having problems? I'll remind you guys to do this until you do it all out of habit. Go to your preferences, and everyone change your code font to Consolas, because life is much easier when all of your characters are the same width. Okay, so let's take a slightly closer look then at these last couple of lines. All right, so what happened when we added in this string inside the parentheses for raw input? So how did that change the behavior of raw input? Shout it out. Come on, don't be shy. A's all year for the first person that answers. Okay, that was a lie, but still. Okay, so, right, so you see before, when you just had raw input and you didn't put anything inside the function, it just sort of goes with this little sort of uninformative default prompt. And you're just supposed to, I guess, kind of know that, like, that little arrow means enter some text here, right? But you see if you put a string inside of the parentheses when you use this raw input command, what that's telling raw input is this is the prompt that I want to use, right? So you'll see what happened is now it's printing out your prompt before it leaves you space to type something in, right? And it'll print just literally whatever you ask for, right? So like some of you probably omitted this space here. This is a very minor user interface thing, but that would mean that like there's no space in between here and here, which doesn't really matter, but these are the little things you would think about if you were a programmer back in like 1986 and all of your programs had text interface with the users, making it nice and easy for the user to see where they want to type in text, right? So raw input will literally print this on the screen and then stop and wait for you to put your input in as usual and hit enter. And then what's happening here in this line? So we have printing, thanks buddy, your last answer was. So it prints everything literally up to here, and then we've got this weird %R, and the string is done, and we have a %, and one last answer. Now I think this kind of gets into one question on your homework, so we don't need to explain it right here in class, but you can kind of see roughly what's going on here, hopefully, right? So some of this is printed literally, and then it looks like something else is happening. So we'll let you kind of think about that. But at any rate, that lets you know that the print command can do more than just print, literally a string. You might be able to print some stuff with formatting or put some variables in or this or that. Okay, so everyone okay with the basic input-output demo? Again, I haven't fully explained all that print can do, because that can be sort of a thought question for the homework and to talk about in the future. And we might play around a little bit more with that, but that kind of gets the basics out. Okay, great job so far. Everyone is an ace programmer. Okay, so program flow. So let's talk just a little bit about what I mean by program flow, and then we're going to use these skills for the rest of the class today to build some more complex programs. So as you might be able to guess, a program that just runs a list of commands like straight down the list in straight linear order is probably not going to be that interesting, right? So what we've done so far, it's kind of cute, but like, what can you really do with that, right? So a lot of times when you're programming or doing any sort of task, you'll want to do the same thing more than once, or you might want to do different things in different circumstances depending on what the current information you have at the time is. So we're going to talk about a couple things that let you do these, one of which is loops. So a loop is something that lets you execute a series of commands more than once, so you don't have to like type it in 50 times. You can just say, do this 50 times, and it'll do it. So an obvious example of this is trials in a cognitive task, right? So if you have a task with 20 trials in it or something like that, you can have a trial set of commands, and you can just tell it to loop 20 times. This is very similar to what you do in E' if you're familiar with that, right? You'll have a list of trials, and you'll just loop over them. And you also have things like if-then statements, which are kind of exactly what they sound like, that let you say, if this is true, then do this, but if this other thing is true, then do this. And you can go on like that forever, but if this other thing is true, then do this, and so forth, right? And you can see why that would be useful. So for example, if you wanted to give feedback, you might say, well, did the participant answer correctly? If they did, then say, great job. And if they didn't, then give them a strong electric shock, or something like that, right? So, you obviously want to use these if-then statements a lot for making decisions based on what has happened previously in the program. Okay, so one way we could represent a program is with something like a flowchart. You often see people do things like this, right? So what we're going to be working with for the rest of the class today is that number guessing game we kind of talked about last time, right? Where I'm saying, I'm thinking of a number between 1 and 100, or between 0 and 100. Can you guess it, right? So this is, we sort of said last time that thinking about different algorithms for this number guessing game, there are some smarter ones and some not so smart ones. One not so smart but very easy one is to say, let's start with 0. Guess that number. Is it 0? The person tells you whether or not it's right. If it's not right, you say, all right, well, let's add 1 to my current guess. So now my current guess is 1. Is it 1? No. Is it 2? No. Is it 3? No. Is it 4? No. Is it 5? No. Right? So we talked about doing this last time. This is one way to guess the number. It's not a particularly efficient way, right? And eventually, you'll say, is it 73? And they'll say, yes. And then you'll go, yay, and you win, right? So this is one way to represent a program that plays this guessing game in a kind of dumb way, right? You've all seen flowcharts before, probably. You probably made them in Microsoft Visio or whatever you use to make flowcharts. But the key thing is, we've got a couple of these programming concepts in here, right? So this kind of forms a loop, right? And it's literally, if you squint your eyes a little bit, it looks kind of like a loop, right? You're going in a circle command-wise, guessing, checking, adding 1 to the guess, guessing, checking, adding 1 to the guess, right? So that's a loop. And this green box with this yes and no represents an if-then statement, right? So if it's right, then stop and celebrate victory. If it's not, then keep doing the loop, right? Everyone see how these two ideas are embedded in this flowchart? Now, flowcharts are an okay way to express algorithms or logical processes, but they're actually not really great once you get into more complex processes. So a better way would really be to start using our old pal, pseudocode, unless you're ready to write real code, and start thinking about the flow of the program in this pseudocode. So if we were writing some vaguely Python-like pseudocode, it might go like this. So we could say, all right, we've got some comments in here, the green stuff, explaining what we're doing. So we say we want to start guessing at 0 and work our way up. So we might take a variable and call it current guess. All right, so now we're using variables for something a little more interesting. And set that to be 0, right? Because we know we want to start at 0. And we have some other Boolean variable called guess is wrong, right? So when guess is wrong is true, that means our current guess is not correct, right? And we're going to assume that we're wrong at first, because what we're going to do is we're going to loop through and keep guessing as long as our current guess is wrong, right? So unless we want to stop the program right away, we should assume that we are starting out guessing wrong. You'll see why this works in a minute. And this is the basic syntax of a Python while loop and a Python if statement. And I haven't really explained what these are yet, but just bear with me for talking about the algorithm. So basically our algorithm is going to be, while the guess is wrong, so as long as we haven't guessed right yet, we're going to put a new value of guess is wrong, or get a new value of guess is wrong, based on somehow asking about our current guess, right? So we'll have some way of asking someone whether our current guess is right, and if it is, guess is wrong will become false, and if it's not, guess is wrong will stay true. And then we might say, if the guess is wrong, then we'll increase our current guess by 1. So current guess will equal current guess plus 1. And we haven't done any mathematical functions yet, but this sort of can forecast what we're doing here. Current guess plus 1 literally means what it looks like, is 1 more than current guess. And you can say current guess is assigned to the previous value of current guess plus 1. Does that kind of make sense to everybody? So we're just adding 1 to current guess by saying whatever the value of current guess plus 1 is, set current guess equal to that now. All right? And then you're going to keep doing that loop until guess turns out right, so guess is wrong becomes false. When this condition is false, this loop ends and we celebrate victory. Okay? So that's how we would express this in pseudocode. I know we haven't really talked about how these while and if statements work yet, but this would be kind of a pseudocode for this way of doing a number guessing game, right? So maybe actually let's do, since it's not quite 3 o'clock yet, let's do one demo based on this, and then maybe take a break, and then we'll sort of make it a little bit more sophisticated, okay? So everybody cool? All right, so let's go back to our PsychoPi. Maybe make a new one, and make sure I've got my notes so I do this right. All right, so let's call this, I'm going to save a new file. You can overwrite the old one if you want, or whatever you want to do. So I'm going to call this numberguess1.py. Okay, so we can say something like, oops, I want you to think of a number between 0 and 100. Okay. Everyone's cool so far? Yeah, you can just follow along with me for this next little bit. So let's get through these first few lines, and then we'll see what we're doing. Okay, so let's just go this far and stop, just to sort of make sure we get through like the introduction part of this. So try a little exec file. Oops. Number guess 1.py. All right, so if you typed in these first 4 lines of real code correctly, it says, I want you to think of a number between 0 and 100. When you have one, press enter to continue. All right, I'm going to think real hard. I've got one. I press enter. It says, OK. I'm going to try to guess it now. All right, great. So that's all it's done so far. So the only thing, right, so all we've done so far is we've just printed out basic statements, like I want you to think of a number between 0 and 100. Why did I use raw input here? So do I really care what you type at that point? What do you think? So did I actually put in any input? So I could do it this way. Number guess 1.py. Oops. Help, I'm trapped in a programming class. Okay, So it does the exact same thing, right, if you type something in there. Because really, all we're telling people is when you have a number that you're thinking of, press enter to continue, right? So, you can do little tricks like this, like use an input function just to pause the program temporarily, even if you don't care about what the input is, right? You're just kind of holding up for a second until someone hits enter. Is that clear to everybody so far, what we're doing in these first few lines? Everybody cool with that? So, there's no law when you get some input from raw input that you actually have to use it, right? You could just be using it to temporarily pause the program. All right, so everybody cool so far? All right, so now it's going to get a little crazy, so just hold on to your hats. So some of this will look familiar from that pseudocode we just did. So we're going to create a variable called current guess and set it to 0. Remember, this is a really dumb program. And we're going to create a variable called guess is wrong. Oops, and set that equal to true. Because, again, we're sort of assuming our guess is wrong. And then we're going to make our first while loop. So while guess is wrong. And I'll tell you right now, this is something you're going to forget. When you have a while statement, you have to end it with a colon. Okay? So make sure you get a colon in there. Now, Python will probably automatically add an indent here, right? So there should be 4 spaces on the next line for whatever you type in. And that's actually pretty important, and we'll talk about that in just a second. So then we'll say, is it, oops. So we're going to have to go through this line by line in just a second. So just type and get used to typing code for the moment, and then we'll see what it actually does. I don't know if the Windows version has this, but there's a weird little bug in the Mac version, at least, where it makes 4 spaces but puts your cursor on the 3rd space. I'm not sure why that is. So just watch out for that. You might have to arrow over. Okay, so answer equals raw input. See, it happened again, so I have to move my cursor over. If answer, because you want all your lines. I want to make sure, this is one reason that you want to use a font like Consolas where all the characters are the same width. You always want to make sure your lines add up, and we'll see why that is in just a minute. Answer equals y. So another 4 spaces in. Guess is wrong. Oh, so answer 2 equal signs, and then yeah, sorry if it's a little blurry on the projector. And it's a y in single quotes. So I think what we're going to do is, we'll see if mine works first of all, then we'll get everyone's working, and then we'll go through and try to actually explain what's going on. All right, we're almost done. So delete all these extra spaces, and print. All right, so all done, I think. Now we get to see if I have any typos in my code. So work on trying to get this code in, and then when you get it in, let's try to run it and see if it actually works. And then we'll kind of step through it and see why it works. Oops. Number guess 1.9. Okay. So mine is telling me I want you to think of a number between 0 and 100. When you have one, press enter to continue. So let's say I'm going to think of the number of 7 just to keep things simple here. I'm going to try to guess it now. Is it 0? No. Is it 1? No. Is it 2? No. Is it 3? No. Is it 4? No. Is it 5? No. Is it 6? No. Is it 7? Yes. Yay! All right. So mine works. Now let's maybe take a debugging break and see it. All right. So let's step through this just a bit and see if we can figure out what some stuff is doing. Now, probably we won't make it all make 100% sense by the end of today, but I think you will get more and more used to these structures and these commands as we go on, and problem set 2 is probably going to focus on exploring these a little bit more. Problem set 2 does not yet exist, but problem set 2 will be based on what we get through today and next week. So I think we'll focus a lot on exploring these loops and things a lot more. Okay, so a lot of things people learned while doing this, one of which a lot of you learned the hard way is that Python is very picky about how your lines line up, right? So this is one reason I keep, I think it's really important that you change your code font and comment font to either Consolas or another font. Basically, you want a font that's what we call monospaced, meaning that all the characters are the same width, right? Because then your spaces are your same width as your W's and your I's and everything. And that way you can really easily tell when stuff lines up and when it doesn't, right? So you can like move your cursor and check that there are 4 spaces here, right? And that there's 8 spaces here. But it's nicer if you can just tell by looking that things line up. Now, the question is, why does Python care so much about why stuff lines up? Does anyone know? Anyone get an idea of why, based on what the code does here, why it matters that things are indented the way that they are? Do you have an idea about that?
Because the one under depends on the one above.
Yeah, if I think you're saying what I think you're saying, which is, so if you have a while statement, right, and you want to do some sequence of commands as long as the condition guess is wrong is true, so right, as long as your current guess is wrong, you want to do a certain set of things. The way you tell Python which chunk of code corresponds to what you do while that condition is true is it's all the things that are indented below the while statement. Does that kind of make sense? So you see, it doesn't do this every time it goes through the loop, right? It only prints that at the end when the statement, when guess is wrong becomes false. Does that make sense to people? So what's indented defines basically what we call a block of code. So a block of code that's all indented, like everything that's indented the same way constitutes a block of code. So everything that has these 4 spaces in front of it is what gets executed during the while loop, okay? Yeah, Ian?
Does your while thing, does that always have to be a Boolean thing, or could it be a number as well?
Well, you have to ask the hard questions, don't you? I mean, the answer is it has to be something that can be interpreted as a Boolean value. But Boolean values really, if you really get down to the dark bowels of the computer, Boolean values are really just integers. And true is really just 1 and 0 is just false. It's just a way to refer to things.
Yeah, so I just noticed that you didn't have to put, like, guess is wrong, say it equals 1 or whatever.
Oh yeah, so, right.
It just assumes you want it to be true.
Right, so this is why we have Boolean values and why we have integers and things like that. So the real answer is, in Python, types of data are very flexible. So like, you can imagine that if you have something that's you're calling true or false, but maybe, well, let's see if I think this will work. Let me just see if will work. This is a bit weird. Right, all right. So if I want to ask, this is a bit funny, what true plus true is, the answer is 2, which is again very like sort of a mystical statement to make. What is this? Or actually, if we want to add false plus false, that's 0. True is still true. So 2 wrongs do not in fact make a right. All right. So false plus false is still 0. True is true. Ah, sorry, I'm running off the screen here. But if we want to say like what is false plus true, we get 1. So what's really happening deep down within Python is that a false is really a 0 and a true is 1. But if we use it in a Boolean context, it's easier for us to not get confused about what's meant to be a number and what's meant to be a truth statement. You know what I mean? But if you sort of force things into a context where they need to be interpreted as integers, you can trick Python into saying, okay, well, this is really just 0 and this is really just 1. Does that kind of make sense? So in a similar way, if you said, I think you can, I get a little bit confused about what you can do in Python and what you can do about in, oh no, so that doesn't work. So in Perl, in some languages, you can like do things like add in strings that represent numbers and get the sum of them, but that's a little bit, this is getting a little bit advanced. The basic point is, what is expected after the word while is something that can be interpreted as a statement of truth, right? So it could be a Boolean variable, but it could also be a condition, right? So this is an if, but the same thing is true, right? So for an if or a while statement, you need to have a condition after that that can either be a variable representing true or false, or a statement that can be true or false. Okay, so we'll get to that actually a little bit more in just a second. But yeah, so in answer to your question, like any integer that's not 0 would equate to true. So, yeah, you could have a statement there, you could have a number, you could have lots of things, but most of them, it gets very complicated. You can even have weird things like lists in there, but that gets kind of funky. So we're not worrying about that for now. Okay. But getting back to what we were saying is, so everything under the while loop that's got these 4 spaces indented is the block of code that executes whenever the while statement is true. Everybody cool with that so far? So you have while, and then some condition, and a colon. And if that's true, it does all these things that are indented similarly. If it's false, it stops doing them, and it goes down to the next thing after the while statement. Okay? So the next thing being something that's not indented relative to the word while. All right, so everybody cool with that? So now, this line, you can probably get more or less what it does. Like I said, we're not talking too much about what this weird %r does and this %sign and the current guess, because that sort of comes up on your homework, and I don't want to give away the answer any more than I have. But you can see that what it's doing is printing is it, and then whatever your current guess, right? And then this should be a line that's well familiar to you by now, answer equals raw input. That is just having you say yes or no, right? And it's suggesting to you that you should put in y or n. Now, do people try putting in stuff other than y or n just to try tricking the program? Did anyone try that when they were running it? You can do it if you want. It's not going to break anything. But you can probably, you can try that out right now if you want. But if we step through the rest of the logic, you can probably see what's going to happen. So what are we doing here in line, what is that, 12? We say if answer, we have 2 equal signs here, and y in quotes. So what are we trying to do there? What does it mean if we have, I mean, I haven't told you this yet, but what does it look like we're asking right here? So we want to know if something is true. What do we want to know? Come on. Nobody wants their voice on the podcast, do they? Okay, so we're testing to see if, so we said that whatever you enter as your text here goes into the variable answer, right? So what we're doing here is we're trying to test if that string that you answered is equivalent to the letter y, right? So we can actually, so if you haven't noticed what I was just doing down here, if you want to just try things out in Python, you can just enter random statements here on the Python command line if you want to see what they are. So for example, if I want to see if the string y equals another copy of the string y, I can do that. And it's like, yes, that's true. Now, is the string y equal to the string no? No, that's false. Is the string me equals... Oh, that doesn't like that. Oh, what did I do there? I did something very bad. Yes, I accidentally only put 1 equal sign. I'm going to tell you now, you're going to do this a million times, and you're going to hate yourself every single time until you finally learn 2 equals means you're testing to see if 2 things are equivalent. 1 equal sign means what we did before, which is you're assigning a value to a variable, right? And it correctly said, now it's not a very helpful error message, but it's saying like, you can't make me equal to Matt because me is already a string. That's not a variable name, right? So what I really wanted to say was me equals Matt. That's false, even though I am Matt, right? But me equals me is true, right? Because those are 2 identical strings. Now I can even do something like this. We can say like my first name equals Matt. Now, if we say my first name double equals Matt, is that true or false? That is true. My first name is Matt. Now, if we want to know if my first name equals Johnson. What did I do wrong there? I only used one equal sign. So instead of testing to see if my first name is equal to Johnson, I instead made my first name equal to Johnson, right? So if I type my first name, or if I say equivalently print my first name, it foolishly assumes that my first name is Johnson, which is not right. Does that make sense to everybody, the difference between one equal sign and two equal signs? So sometimes when you use the wrong one, you'll get an error message and you'll go back and find it. Other times it will lead to really sort of tricky to find bugs where you accidentally, instead of testing to see if two things are equal, you accidentally assign a variable to a new value, value when you're actually trying to test if it's equal to that value. Okay, does that make sense to everybody? All right, so going back to the actual code we entered. So we want to know if the answer that they entered is equal to the character y, so just the string y. We set guess is wrong to be false, right? So what that's going to do is, when we get back up here, when we finish the chunk of code under the while loop, and go up here to check and see if it's true again, guess is wrong is now going to be false. So this condition is no longer true. So we skip out of the while loop and skip to the end, right? So whenever someone answers y, we set the condition that the while loop is based on to false, and then we pop out of the loop and go to the end, which is, to say, I'm awesome. All right, does that make sense to everybody? Now, you've also seen now what you can do here, which is you can say else, which just means, like, if the answer is true, we do this, or sorry, if the answer is y, we do this. In all other circumstances, we do this. So that's what else means in this context. So, if, the person says, I want to continue with this task, do the task. If they say anything else, bail out, right? Or something like that is where you'd use else, right? So if they say anything but the letter y, you say current guess is equal to current guess plus 1. Now, I think you can see what that line is doing. So let's just call a variable like guess and call it 0, right? So if we want to see what guess is, it's just 0. If we want to see what guess plus 1 is, somebody's got a text. So guess plus 1 is 1. All right, so you can do regular mathematical operations here. So if I said that line and I put guess in again, what are we going to get here? We're still going to get 0 because I didn't change what guess is, right? So I can see what guess plus 1 is. I can see what guess plus 50 is. But until I reassign it, guess is still 0, right? But if I want to say guess is now equal to guess plus 1, now guess is 1, right? Or if I want to say now guess is equal to guess plus 10, what is guess going to be now? 11, right? Okay, so what you have here, so it's totally valid, and you do this all the time in programming, so don't be afraid of doing this, although I know it looks a little bit weird sometimes the first time you see it, is you can assign a variable to a new value based on its old value, right? So when you have an equal sign, the Python knows to go ahead and evaluate or go ahead and figure out the value of everything to the right of the equal sign before it does the assignment, right? So it figures out what guess plus 10 is before it assigns this. Now we could also, say like second guess equals guess minus 2 or something like that. Now what would second guess equal? 9, right? But what is guess? 11, right? Okay, everybody cool with this idea? So whatever's on the left of the equal sign gets the value that comes out from this statement. And it either can be the same variable as used in the statement, or it could be a new variable, right? Is everyone okay with that? So you can do whatever you want to on the right-hand side, and then whatever the result is gets stuck over on the left-hand side of that statement. All right, does that make sense to everybody? So going through the while loop again, Going through the while loop again. All right, so we print out, is it this? We get a raw input. We test to see if they answered Y. If they did, we say guess is wrong is false, so we pop out of the loop. Otherwise, we increase the value of current guess by 1, right? And then we keep doing that over and over until you answer Y. Now, what happens if you answer, like, instead of answering N, it tells you to answer Y or N. But what if you answer something like, no, you are incorrect? What does it do there?
It's the same as answering N.
Okay, it's the same as answering N, right? Because we're never actually testing to see if they entered N. We're just testing to see if they answered Y, right? So what if you answer YES enter? What is that interpreted as? That's still interpreted as no, right? Because we're only testing to see if they answered exactly Y, right? So we can even, I mean, if you want to see, let's say exec file, number, oops, guess what I didn't do? Number guess 1.py. Oh, what did I do? Oh, no such file or directory. I have to do that same trick I was trying to avoid having to tell you guys. Number guess 1.py. Okay, so I'm going to guess the number 0, or I'm going to think of the number 0. Is it 0? Yes, it is. Damn it, I said it was 0. So right, so it doesn't know to test anything but Y, or anything but Y, right? So again, this is fine in this simple little program, but this is the kind of thing you always want to be thinking about when you're writing a program. And actually, Ian and I, and maybe a couple of others, might be able to remember the dark days of like the 80s, when you would actually have computer programs that would run on like old Apple IIs that would have interfaces like this, and it would be like, do you want to load the next level? And you type YES, and it would quit because it's only expecting the letter Y or something like that, right? So this is, at the very lowest level, this is, you have to start thinking about your user interface. Like, is it okay if the only thing it understands is Y versus everything else? Or do you want it to be a little more flexible and accept Y or yes or sure thing or, you know, whatever, right? And this is the same issue that, you know, you run into if you are using something like Siri on your iPhone, right? What things does Siri understand and what does she not understand? You have to explicitly put in everything that you expect the user to do, or else it's just going to default to saying no, right? Okay. Anybody have any questions about this simple number guesser program? Does everyone kind of get how everything works here? Okay. Is everybody cool with that? I don't want to go too fast or too slow. All right. So let's talk a little bit more about a few other topics here. And then we'll maybe revise this 1 or 2 more times. And then we'll call it a day. So, all right. Oh, actually, forgot one other thing. Sorry, one other thing I wanted to point out about this program. I don't know if anyone's noticed it yet. There's one reasonably substantial problem with this program if the user disobeys or makes an error in some way. Anybody know what it is?
It's in the slide notes.
Oh, did you already see it? Oh, shoot, I forgot.
Just read about 5 times.
Sorry about that. Okay, right. So there's a bug that, stupid slide notes. I'm not used to using mirroring instead of the one where you guys can't see what my slide notes are. I hope I didn't say anything bad about you guys in my slide notes. Okay, so yeah, so the issue is this is a while loop, right? And all the while loop does is say, is it this? If you don't answer yes, it increments by 1. So if the user, you know, say you had 23 in mind, but then it was guessing 1, 2, 3, 4, 5, and you're hitting no every time, that's fine, and you accidentally hit no when it is 23, this thing will go on forever, right? It'll go past 100, it'll go to 1,000,000. It's like a dog. It's like your dog throwing the tennis ball, right? It'll keep chasing that tennis ball as many times as you throw it until you finally give up and say like, oh, okay, yes, fine. So it doesn't actually know to stop at 100. So there are some non-optimal things about this program, but the next thing we do will actually let us sort of fix one of those bugs. Okay, so we've done a while loop now. So there are different kinds of loops that you might want to use in for different purposes. So this while loop is useful if you want to keep looping forever until a certain condition is satisfied. Next, we're going to introduce for loops. which are if you want to loop over a certain range of values and then stop and not necessarily go forever. And then there are also time travel loops, which allow you to go back and kill people by sending them into the past. I saw that movie this weekend. All right. Anyway, so if you haven't seen it, it's very good. Also very violent. Okay, so let's talk about the difference between for and while loops. So while loops are what you would generally use when you're waiting for something to become true, but aren't sure exactly when it would become true, right? So for example, if you're running a cognitive task and you want to keep running trials until someone has reached a certain performance level. So until they get to like 75% accuracy, keep going. So, and again, I'm expressing it this way because you have to start sort of thinking in the syntax of the programming. So while it's true that the participant has not reached the criterion, keep running trials, right? So in other words, keep running trials until the person reaches criterion. That makes sense? So that's a reasonable circumstance. Or you might say, while the person has not yet made a button press response, wait a couple of milliseconds and then check again. Now, we haven't talked about how to get keyboard responses in PsychoPi yet, but this is something you'll actually have to do. You'll have to actually, in PsychoPi, one of the sort of a downside is that if you're writing straight code, you have to manually check for responses every time you want a response. So you say, all right, well, have they made a response? No, check again. Have they made a response? No, check again. All right, so that's another useful case for a while loop. Going back to that algorithm we did last time for coffee making, you might say something like, while my coffee cup is not yet full, let the water run for a second and then check again, right? So all things that like you don't know, if you don't know how big the coffee cup is, you might wait 2 seconds for the water to fill it up or 3 minutes if the water runs really slowly. So you just have a while loop and say, well, until it's full, let the water keep running and then keep checking, right? Everyone, this all makes sense to people why you would use a while loop? Okay, so here are some examples where you'd use something called a for loop. So this is when you want to do something a certain number of times or do something like for a certain number of items in a list. So some examples of this is for 40 iterations, run a trial of my task, right? Very common thing you might want to do in cognitive psychology. Or for 4 iterations, run a block of 40 trials, which might use another for loop with some breaks in between, right? So this is, you've probably done this in ePrime before, where you have like a block list of things to do, and then within that block list, you might have a trial list of things to do, right? So this is something we call nesting loops, and I'll definitely make you do this in problem set 2, but we won't be doing that quite yet today. Or something like, for every person in the room, make them a cup of coffee, right? So this is a case where it's not that I necessarily want to make 10 cups of coffee, or 20 cups of coffee, or 50 cups of coffee, but I want to make a cup of coffee for every person in the room, right? So I might go down a list and say, it's like Oprah, like, you get a cup of coffee, you get a cup of coffee, you get a cup. Anybody watch Oprah? All right. So you can loop over items in a list, right? You don't have to loop over just a certain number of things. Okay, so you guys want to try this out with a for loop instead of a while loop? Well, whether you like it or not, we're going to. So here we go. All right, so I'm going to just save this as number guess 2 in case I want to save my beautiful code and make a few changes to the code, okay? So let's see. What do we want to change and what do we not want to change? So the first line's okay, right? This is all fine. Press enter to continue, print okay. I'm going to try to guess it now. That's all fine. But we can actually make this a bit shorter if we change from a for loop to a while loop. So we can get rid of those lines where we set those variables, and instead, let's change this while loop to a for loop. And we're going to say for current guess in range, parentheses, 100. Still leave that colon in there. Oh, and this is worth noting. This program will have the same bug as I asked about in problem set 01. So I won't tell you what the bug is, but just know that this does have a built-in bug that I already asked about in the homework, so I won't ask you about it right now. So we're still going to want to print, is it the current guess? Still want to get raw input, but we're going to change the rest of this a little bit. Get rid of all this and just replace it with the statement break. Now, I didn't tell you what break did yet, but that's okay. We'll find out very soon. Okay, so that should be all the changes you need to make. Let's see if I did this all right. And then we'll step through that as well. Okay, so let's say I picked 5. So, nope. No way. Negatory. False. Wrong again. You see how we're still only testing for y. Is it 5? Yes. All right. So it looks like this mostly works. All right. So now the question is, what are we doing here? Well, first of all, I guess let's take a little break and let everyone type this in and see if they've got it working. This is where I will confess, like, keeping in mind that I'm myself kind of a Python noob. I know the basic answer to this, but I always forget the exact syntax in a certain language, but I think you can do this. Let's see if I'm right. I think it's the word or in Python, because it's different. Or is said in a different way in different languages, but I think it's that in Python. Yeah, I mean, this is getting well beyond the scope of this course. There are also different types of ors in different languages, like there's bitwise or and logical or and things like that. So, no. Oh, wait. Okay, clearly I didn't do it right. Oh, you know what I didn't do? I don't think I saved it. Let's see if I... Oops. Now you're going to get to see me try to figure this out. I mean, the answer is yes, there's obviously a way to do that. I just have to remember the exact phrasing.
You might want to call them this too,
Oh, thank you, Chang. That would be one thing, is making sure you're running the right file. So yeah, we may have all not had bugs because we forgot to change the file name that we're running. All right, so that would help. So exec file number guess 2.py. So now we'll probably find all kinds of bugs that we didn't see before. So is it 0? No. Is it 1? All right, yeah, so that would be how you do it, is you could say, or the main things to check here. So there are a couple new things we introduced, right? So we changed the while to a for, and the for line looks like this. We also added this break thing, right? So again, I don't want to get too deep into this because I think there's a line or two about this in your homework as well that is still not due till Friday. But what is this basically doing every time it goes through the loop? What happens to current guess every time you go through the loop? Well, what happened? I mean, it asks, is it 0? Is it 1? Should go on in theory, right? So current guess is getting a new value every time it goes through the loop, right? So just like the while loop, it takes everything that's indented similarly and runs it as a loop. But unlike a while loop, which just runs the same code every time, the for loop changes current guess every time you go through it, right? So it starts out being 0, apparently. The next time through, it increases it to 1. The next time through, it increases it to 2, and so forth. And something about this part in range 100 is telling it to do this 100 times, right? Now, again, the details of this kind of relate to your homework, so I'll let you figure it out in the homework first. But does everyone kind of basically get what's going on in the for statement? How you're going to go through 100 times, and each time current guess is going to get a new value starting at 0, right? Is everybody cool with that? Okay. So the other thing that we changed here is instead of all these things where we have a condition that we change to false and all that other stuff, we just said if the answer is y, or in this case if the answer is yes, we break. So what is break doing basically? Right, it breaks the loop, right? It's like when you kill your younger self or kill your older self or whatever in Looper, right? So yeah, you're effectively saying, hey, you know that thing I said earlier about do this 100 times? Don't do it 100 times. Just stop right now, right? So as soon as you say break inside a for loop, it just is like, all right, never mind. And says, I'm done, right? So that's what break does. So this is, if you are implementing this very dumb number guessing program using a for loop instead of a while loop, this is how you'd have to do it. Because if you didn't say break, it'd be like, oh, good, all right, I got the answer right, and then just keep going, right? So you need to make it say, all right, well, start out assuming you're going all the way up to 100, but we may stop you along the way, right? Does that kind of make sense to everybody? So this is one way you get out of a for loop early if you need to. Now, I should mention, actually, you also can use the word break in a while loop if you want to, but more often, it's not really considered good style to use break more often than you need to. This is kind of a finer point, so it's not too important. But generally speaking, in a while loop, you can generally just change the condition that makes the while loop run. So you don't usually need to use the break statement too much in a while loop. But in a for loop, sometimes you do want to run something a set number of times, but possibly stop it early. And then it's perfectly acceptable to use this break statement. Okay, so any other questions about how this program operates? Everybody kind of cool with that? All right, so we've only got a couple minutes left, but let's go through a couple more slides here. We've actually only got a couple more slides, but we can pick up where we left off next week. So, all right, so this was going to be the workshop, which we clearly don't have an hour for, because we're basically workshopping the whole time, but that's fine. So what you've already done, so we've already managed to write 2 different programs, each doing this very stupid number guessing game using for loops and while loops, right? But this is actually good because if you can do an if-then statement and if you can do a for loop and a while loop, that is most of what you need in terms of program flow commands to actually write a real program in Python, right? So it's really important to understand the for and the while statements and ifs and thens, pretty well. And then you can do a lot of things with it, right? So a question that we're going to address as we sort of go through the workshop is, can we make a smarter version of this game? So we talked about this a little bit last time, right? So what's a smarter version of doing this? And we talked about some pseudocode, which I think we sort of talked about last time, but you didn't really know what the syntax looked like as much. So it'll hopefully make more sense now. Or maybe we didn't have the pseudocode for this before. We had the pseudocode for making coffee. But anyway, hopefully the pseudocode will start to make more sense to you as you learn more Python. So our previous way of doing this, right, was doing the while loop. And we say, well, as long as our guess is wrong, ask about the current guess again. And if it's still wrong, add 1, right? That logic makes sense to everybody? So some new pseudocode for doing this a little bit smarter, we can make this a little bit more sophisticated, right? So we could say, let's not start at 0, let's start at 50, right? I think I made Bruce do this last time, right? He said, all right, well, it makes more sense to start somewhere in the middle if we say, well, let's change the game a little bit so that we can let the person say it's higher or lower, okay? So we don't only say, yes, you've got it right or wrong. You can say, all right, it should be higher, it should be lower. So we could say that. We could do it, again, going back to a while loop, and say, while the guess is wrong, ask about the current guess. If it's still wrong, if it's not still wrong, we can just celebrate victory, right? All right, you know what? There's no, actually, we're good, we're good. So if the guess is wrong, we can also ask if it's higher or lower. If they say it's higher, then we're going to have to do something to guess higher. And if it's lower, we're going to have to do something to guess if it's lower. And I slipped in another slightly different command here, which is the elif, or the elif statement, which is shorthand for else if, which is usually how it's printed in other programming languages. Python's a bit weird. It likes to make up words. So this is one way we could also get around that issue we had before where you had to either type y or n. So you can explicitly say, if something's equal to higher, do this. Otherwise, not just otherwise for all other conditions, but otherwise, if instead it's this condition, do this. And then we could have a bunch more elifs if we really wanted to, okay? So I slipped in a little bit of new syntax here. Hopefully that makes sense. Now the question is, of course, how are we going to guess something higher or lower, right? So you probably have an intuitive sense of what this algorithm is, so you probably can think, all right, well, let's say the number you're trying to guess is like 67. So you're going to say, is it 50? They're going to say, no, it's higher. You're going to say, is it 75? They're going to say, no, it's lower. You're going to say, is it, what's halfway between 50 and 75? Like 63 or 62, right? Is it 62? No, it's higher. What's halfway between 62 and 75? It's like, okay, so that's going to be your basic algorithm, right? Is you're going to want to go halfway between your current guess and whatever the other end of the range is, right? But we have to figure out some way of how we represent what that range is, right? So that's going to be the tricky part of this next program we write. And I don't think it's worth actually getting into now. I think we can maybe start that in the beginning of next time. But that's worth just kind of thinking over how you would do that. What new variables you're going to have to add. We don't really have to add a bunch of new syntax. Like I'm not going to teach you, aside from that elif thing, which is really just to sort of improve the user interface. There's not going to be any new syntax. So you could write this based on what you know already. But how would you write an algorithm to figure out, what's halfway between my current guess and some other end of the range, right? So you can do this intuitively. You can say, all right, I'm going to go 50, 75, 62, whatever's halfway between there, like 68, 72, whatever it turns out to be, right? So you can do this roughly in your head, but you have to think about how you would tell the computer to do this. So next time, maybe we'll start with that and work through that. Okay, any questions about any of that? And next week, we'll do real PsychoPi stuff, not just using the program PsychoPi to write plain Python, but using actual PsychoPi commands to put stuff on the screen. And that'll be exciting. All right, any questions? Rock on. All right, cool.